This presentation will be discussing the 400 series KTUs. I have in the video at this moment a Western Electric 400 KTU on the left side, and next to it I have a 202D 1A1 line circuit. Both of these perform the same exact function. The 400 KTU was the next generation of advancements in the 1A key equipment, or actually 1A1, 1A2. It was designed to be modular, so you could change out the cards if there was an issue without having to rewire anything. As where if the KTU, the wire spring KTU, had issues, then of course it either needed to be repaired or replaced, or if there was another circuit not in use, then you would simply move the wiring to that circuit. For this portion of the video, I will demonstrate how the 1A1 line unit operates. The same exact theory will be on the 400 series line cards. Due to the miniature wire spring relays on the line cards, they're very difficult to actually see them operate without a camera with a very good lens. So I have a 2565 that does not have a mounting cord on it, so I have actually wired up the wires directly from line 1 of the key strip over to my 202 KTU. It would be exactly the same electrical principle if we had a mounting cord, a cable, 66 block, all run to a central location, and then the KTU is wired to the cable. I've just gone directly from the KTU to the phone. So I will go off hook and you will see the A and the AH relay operate. So we now have a steady light under the telephone. I'm going to place this on hold, and right now the line is on hold. The AH relay is still operated and the A relay has released. When I hang up, both relays will release. During an incoming call, the R relay would operate, and the would then light up the light on the key system. So what I would do is dial a number to ring myself back. And I'll hang up and you'll see the R relay pull up. When you go off hook through the series of the contacts in the A and the AH, it releases the R. Also, if you look at the very top relay, when I press this on hold, that will be operating as well. So right now, the H relay is operated. The phone line is actually going through the relay coil to hold the line up, and then at that time it starts the interrupter and then switches the lamp circuit through to the lamp wink on the telephone system. Going forward, discussing the 400 KTUs, they operate exactly the same, and I will show a variation of KTUs, but I do not have anything wired up, and even if I did, you would not be able to see anything happening. So I will go ahead and release the line and prepare for the next set of KTUs. There are a lot of 400 series KTUs made by different manufacturers. I have 4 KTUs presently in front of us. This is a Western Electric 400G KTU, which was a newer KTU after the 400D issue 15, and then the Western Electric 400H, which was the last KTU that Western Electric manufactured for the 1A2 key telephone systems. we have a K400E line card, which is made by ITT. All four of these line cards are interchangeable in the systems. They all perform the same exact functions. They're just different vintages of line card. You can also mix these types of line cards, so you can have a Western Electric in card slot 1, an ITT in card slot 3, a Stromberg, for an example, in card slot 4. They'll work perfectly fine. I will show some additional cards shortly. The 5 cards that's in the video at this moment, we have a Northern Electric KTU. They call it a QUN10. This is equivalent to a 400D, for an example, KTU, which is made by Bell Canada. Then the next one we have is an ITT 400 TPL, and the TPL stands for Total Protected Line. This particular KTU was used by interconnect companies that did not have an ITT certification on file with the local telephone company. So you could use this instead of a conventional ITT line card. They sucked, but that was something available. Then we have a Sandbar 4000 KTU, which again performs the same exact function as a 400D. And then we have 2 almost electric KTUs. This is a very early automatic electric, and this was a later generation when they changed it to GTE. They are interchangeable with the rest of the KTUs. What's interesting about the automatic electric KTUs, they are probably the only item that Automatic Electric made that was ever interchangeable with any of the other equipment manufacturers. So you could again take a Western line card and replace an AE or vice versa. So these cards, except for the Northern one, are common on eBay. And I have a few more I will show in the next video. This is a Western Electric 400B KTU. It was the second generation of the 400 series line cards. I have a 400C line card, and then I have a Cook Electric 400 KTU. This is an earlier version than the previous one that I showed in the video. Here's all of the KTUs stacked together in one pile. Once again, these all perform the same exact function, and they can be interchanged on any 1A2 system amongst any of the manufacturers. If there is any variations, they would be slight. There are options to be set on each and every card if you want to change them from the original factory default options. At that point, you would need to practice for that specific line card. Some of these cards have the ability to connect music on hold, either with an external piece of equipment or directly to a bus in the KSU. I will not cover that in this video. These 4 line cards that's in the video are the most common and easiest to find on eBay. There was trillions of them made, so they come up from $2 to $100 a piece. The realistic value of these cards is around $2 to $10 per card, depending on how desperate you are to buy a card and so forth. The 400D series card, this particular one says issue 15 on it, and that is an important factor in today's telephone systems. If you're using an analog telephone adapter, also known as an ATA, such as a Vonage Packet 8 or some type of a VoIP provider, you need to have a 400D issue 15 or any of these other 3 line cards in order to detect the ringing signal when the phone number is called. These have the ring up relay circuitry bridged across the phone line. With your ATAs and your VoIP type systems and some digital PBX systems, the ringing is across the tip and the ring pair, the phone line, the 2-wire phone line from the phone company. The 400 series prior to issue 15 needed what was called grounded ringing in order to complete the ringing circuit. ATAs and some electronic phone systems are not connected to earth ground directly or from a circuit standpoint. The chassis may be grounded, but the internals of the unit will not be grounded to complete the loop. Otherwise, you could use any KTU. So if you're using a conventional standard telephone line from a conventional telephone company, pretty much any KTU should ring up without any trouble, as long as the KTU is, of course, functioning. When you get into intermixing phone lines and voice over IP type services, you can run into, if you disconnect the phone line and connect an ATA to that port or that phone line, where that phone line used to be, then you've now got a circuit card potentially that's looking for grounded ringing, and it will not ring up. It'll work fine for placing it on hold, but you will not be able to detect an incoming call. The reason for the grounded ringing in the earlier days was at the central office where the ringing equipment is. One side of the ringing generator is connected to a 48 volt power supply. Then the output is connected to a ringing transformer, which imposes up to 105 volts AC at 20 or 30 cycles onto the phone line, and then it goes out the ring side of the phone line to the KTU, and then through the key system ground, it would end up being grounded, so you would then have a completed circuit. So when they sent out ringing generators on the line, you would operate the line card. Now, there are capacitors on every line card. I don't know which one on this card has to do with the ringing, and that's not the focus of this video. So there's a DC open as far as the ringing plant is concerned, and because you're using an AC signal most of the time, the capacitor will allow AC to pass right through it. So as far from an electrical point of view, you have a complete circuit during ringing. With the modern voice over IP or systems, most of the power supplies are what is called floating. Neither side of the power supply that operates the phone system is connected to ground. So they may ring across the tip and the ring line pair, and if you have a voltmeter on that pair, you will see the ringing. If you take your voltmeter and connect it, one side of it to ground and the other side to what would be technically the ring side of the line, you should not see any voltage. You may see a few millivolts leakage, but you will not see any real voltage. So that's kind of a brief definition of why the 400 line cards need to be at least issue 15 and up. The 400G was late enough that it does not care. The ITT 400Es and most of the 400D line cards don't care. The 400H works fine for ringing detection. But there's one feature that was built into the 400H that makes it a little disappointing from a user point of view. There's a timing circuit in here that when you go off hook on a telephone and try to place the line card on hold, you have to wait a certain amount of time, or the line voltage has to have enough of a change before the KTU will allow the line to be placed on hold. This was done to prevent people going off hook on phone lines, putting them on hold to busy the line out for lunch. In electromechanical ESS offices, such as the number 1E, 1A, number 2, number 3 ESS machines, because they were relay controlled by computers, after the register or dial tone circuit timed out, there was a DC break on the phone line that would release the hold of the line card. So at that point you would actually have to dial your own phone number, receive a busy, unless it was of course a trunk hunting, then it would just ring to the next line on your phone, and then put it on hold that way. So in my opinion, the 400Hs are the least desirable line card, but they still do work. I have a Western 400D issue 15 and a 400D issue 14. You can tell there's additional components on the 14, and the layout looks the same, but there are differences between them. The 400, this particular 400 line card has here some green goo that's leaked out of the relays that are located on the Western Electric line cards, and only the Western Electric line cards. That is a reed relay that's got green goop in it, and the goop after 35 to 40 years has turned into somewhat of a very rubbery, somewhat gel compound, but during the hot temperatures, if it's in a hot room or in a box in a hot building, depending on how the card is laying or sitting, you can get the goop that leaks out on line cards. The only thing I found that even begins to try to cut that is acetone, such as fingernail polish remover, or I've had some luck with denatured alcohol. If a line card starts to leak, it'll still work fine. It just makes a heck of a mess of everything. And if they're mounted in a KTU or key system like this, and 99% of them are, as they leak down, you'll get a green pond on something below this, which then of course makes everything sticky. If you get the green on your hands, you're going to have to use Braxo, gasoline, or fingernail polish to get it off, because that stuff is very, very sticky. So again, every Western 400D line cards will tell you somewhere in the line card what issue it is. So if you're using conventional everyday telco line, this card will work just fine. If you put this on a VoIP service, you'll never detect an incoming call. The one exception to the Western Electric line cards when it comes to the leaky goo is the A, the B, and the C did not have a reed relay on it. These were made before reed relays were widely in use. So this line card will not have anything that will leak out of it. This is a B series, which is fairly common, and this is the C series. And this is the only single C series I've ever had in my lifetime. And I've never seen the 400A, but they do exist, or did exist. So I made a different angle of the 200 series KTU. So I will go off hook, the A and the AH operated. When I hang up, the A will release and the H relay will operate. During a ringing, the R relay would ring up and latch. I've optioned this card for bridged ringing, or this unit. It can be set up for grounded ringing, but in today's world I would not do that. This concludes my 400 series KTU. please provide comments below. Occasionally, a person will run across the 400D KTU that has a capacitor such as what I'm showing right now that was added to the circuit card in the field. This is done only on 400 KTUs that was connected to Centrex systems, basically a number 1 ESS or 1A ESS type switching system. A Centrex, usually for government or business services, would have features on their line such as call waiting, and this would also happen in regular business environments as well. If you had a call on hold and that line had call waiting, the moment that the central office switched the phone line to the 3-port conference circuit to allow call waiting, you would drop the on hold condition, i.e. hanging up on the person that was waiting for you to get back to them. There is no purpose today in 2020 to have these capacitors at all on the line cards. None of your digital switching systems provides DC breaks on the line during a transition for 3-way calling and so forth. That is just not needed, and it's not part of the inherent design of the switch. So if you have a capacitor such as this on here, you can actually remove it. What I would recommend is taking your punch tool and cutting the wire off right here, because you do need the strap between here and here, and then just removing the capacitor off of the board. This way, when the call, if you have a device that does provide calling party control, when you have a call on hold, if the person that's on hold hangs up, it will drop the line card if the service you're using provides the supervision. These wire spring relays are very delicate and should not have their covers removed, and I highly recommend not trying to adjust the relays unless you know exactly what you're doing and what the end result should be. These relays can easily be damaged, and if they're misaligned, you may not have satisfactory results in their operation.